What if I told you that right now, at this very moment, something massive is drifting through our solar system, and we have absolutely no idea it's there? Not a comet, not an asteroid, but an entire planet wandering through the darkness, completely invisible to our most advanced telescopes. Sounds like science fiction, right? But here's the thing: astronomers are now seriously considering that rogue planets, worlds ejected from their star systems billions of years ago, could be passing through our cosmic neighborhood undetected, and some of them might be larger than Jupiter. In the next 30 minutes, I'm going to show you why the evidence for these invisible giants is stacking up faster than anyone expected, and by the end of this video, you'll understand why some scientists believe we've already been visited by one of these cosmic wanderers. But first, you need to know why everything we thought we knew about planetary formation might be completely wrong. So here's the question that keeps astronomers up at night. How do you find something that doesn't reflect light, doesn't emit heat, and exists in the vast emptiness of space? For decades, we've operated under a comfortable assumption that planets need stars. It's intuitive, right? Planets form from the leftover disk of material around a young star. They settle into stable orbits, and that's where they stay for billions of years. This is the model we've taught in every astronomy class since the 1950s. Clean, simple, predictable. But here's what actually happens, and this is where things get disturbing. Computer simulations run by astrophysicist Guy Peretz at the Technion Israel Institute of Technology show that during the chaotic early days of planetary system formation, gravitational interactions between young planets can be catastrophic. One planet gets a gravity assist from another, and suddenly it's flung out of the system entirely like a stone from a slingshot, traveling at speeds exceeding 30 kilometers per second. No star, no warmth, just an endless fall through interstellar space. Now you might think this is rare, some cosmic accident that happens once in a billion years, but the numbers tell a completely different story. A 2011 study published in Nature by astronomer Takahiro Sumi analyzed gravitational microlensing events, tiny distortions in starlight caused by massive objects passing in front of distant stars, and what they found shocked the astronomical community. The data suggested there could be twice as many rogue planets as there are stars in our galaxy. Let that sink in. We're talking about potentially 200 billion homeless worlds drifting through the Milky Way, and statistically speaking, several of them should pass within a few light years of our solar system every million years. Think about what that means. These aren't just theoretical objects, they're out there right now, coasting through the void. And because they don't emit light in the visible spectrum, because they're not heated by a nearby star, they're essentially invisible to traditional telescopes. We've built our entire astronomical infrastructure around finding things that shine, and rogue planets don't play by those rules. But here's where it gets even stranger, and this is the part that made me realize how fundamentally unprepared we are for this possibility. Remember October 2017? That's when our telescopes picked up something that still doesn't make sense. Oumuamua, a Hawaiian word meaning scout or messenger from afar, was the first confirmed interstellar object to pass through our solar system. And it was weird, really weird. Initially classified as a comet, then an asteroid, Oumuamua displayed characteristics that fit neither category. It accelerated as it moved away from the sun, but showed no signs of outgassing, no visible tail, nothing that would explain the acceleration through conventional comet physics. Harvard astronomer Avi Loeb famously suggested it could be an artificial object, a light sail from an alien civilization, and while that hypothesis drew skepticism, it highlighted a more important point. We have no framework for identifying objects that don't fit our existing categories. Here's what most people missed about Oumuamua, and this connects directly to rogue planets. The object tumbled through space in a chaotic rotation pattern and was elongated, roughly 400 meters long and only 40 meters wide, giving it a cigar-like shape unlike any asteroid we'd ever seen. More importantly, we only detected it on its way out of the solar system. It had already swung around the sun and was heading back into interstellar space when we spotted it, which means one terrifying thing. We're essentially blind to objects entering our solar system until they're already here. Now, imagine Oumuamua wasn't 400 meters long, but 40,000 kilometers wide. Imagine it wasn't a tumbling rock, but a rogue planet the size of Neptune drifting silently through the outer reaches of our solar system beyond the orbit of Pluto, where sunlight is so faint that even a massive world would be nearly impossible to see. How would we know? What would the signs be? This is exactly what a team led by astrophysicist Sean Raymond at the University of Bordeaux investigated in 2014. They ran simulations asking what would happen if a rogue planet passed through our solar system, and the results were unsettling. Even a brief encounter, lasting just a few 100,000 years, would leave gravitational fingerprints. Orbital perturbations in the outer planets, slight changes in the eccentricity of Neptune's orbit, unexplained anomalies in the trajectories of long-period comets. And here's the kicker, we're seeing some of those anomalies right now. The orbits of several extreme trans-Neptunian objects, small icy bodies beyond Neptune, show a clustering pattern that shouldn't exist if the solar system has been undisturbed. Astronomers Konstantin Batygin and Mike Brown proposed in 2016 that this clustering could be evidence of Planet 9, a hypothetical super-Earth lurking in the outer solar system. But here's what they didn't emphasize enough. The gravitational influence they're detecting could just as easily come from an object that's no longer there, a rogue planet that passed through, altered the orbits of these distant objects, and then continued on its journey into the cosmos. We might be looking at evidence of a visitation that already happened and we completely missed it. But if that's true, and this is what keeps me up at night thinking about it, what else have we missed? So how exactly do you hunt for something invisible? Traditional astronomy relies on light. We point telescopes at the sky and collect photons emitted or reflected by celestial objects. Stars shine because of nuclear fusion. Planets reflect the light of their parent stars. Even the coldest asteroids emit faint infrared radiation because they're warmed by the sun. But rogue planets, especially those that have been wandering interstellar space for billions of years, have cooled down to near absolute zero. They emit almost no heat, no light, nothing for our telescopes to latch onto. This is where gravitational microlensing becomes critical, and it's one of the most elegant detection methods in modern astronomy. Here's how it works. According to Einstein's theory of general relativity, massive objects bend space-time around them. When a massive object like a rogue planet passes directly between us and a distant star, the planet's gravity acts like a lens, briefly magnifying the star's light. The star appears to brighten for a few hours or days and then returns to normal. By analyzing the exact pattern of that brightening, the duration, the shape of the light curve, astronomers can determine the mass of the object that caused it. The catch? You need to be looking at exactly the right star at exactly the right time. Space is unimaginably vast, and the odds of a rogue planet aligning perfectly with a background star seen from Earth are astronomically small. That's why the microlensing surveys that detected those potential 200 billion rogue planets had to monitor millions of stars simultaneously for years. But even with microlensing, we're only detecting rogue planets that happen to cross our line of sight to distant stars. What about the ones that are close? What about a rogue planet drifting through the outer solar system right now, not passing in front of any convenient background star? This is where things get genuinely fascinating. In 2020, a team using the Atacama Large Millimeter Array, ALMA, in Chile announced they had directly imaged a rogue planet for the first time. The object, designated OTS-44, is only about 12 times the mass of Jupiter, and it's drifting through space completely alone, no star anywhere near it. They found it not by looking for reflected light, but by detecting the faint millimeter wavelength radiation it still emits from its formation heat radiation. So it's like detecting the warmth of a candle flame from 10,000 kilometers away. And this is exactly why I make content like this, because the mainstream science coverage skips over the implications that actually matter. If you want more deep dives into the mysteries that challenge everything we think we know, hit subscribe, and drop a comment telling me which unexplained astronomical anomaly you want me to cover next. Smash that like button if you've ever felt frustrated by a surface-level science content, because your engagement tells the algorithm to show this to people who actually care about the real questions, not just the easy answers. The ALMA detection proved something crucial. Rogue planets can be found if we look in the right way with the right instruments, but here's the scale of the problem. OTS 44 is relatively close in astronomical terms, only about 550 light-years away, and it's still young enough to be emitting detectable heat. An older, colder rogue planet passing through our own solar system at, say, 500 astronomical units, 500 times the Earth-Sun distance, would be exponentially harder to find. Yet some researchers believe we've already seen hints of exactly that, and the evidence comes from one of the strangest places imaginable. Let me tell you about one of the most mysterious objects in our solar system and why it might be a smoking gun. Sedna is a dwarf planet discovered in 2003 by Mike Brown's team, and its orbit is completely insane. While most objects in the solar system orbit the sun in relatively circular paths, Sedna follows an extremely elongated ellipse. At its closest approach, it's still 76 astronomical units from the sun, more than twice Neptune's distance, and at its farthest it reaches an astounding 937 astronomical units. Its orbital period, the time it takes to complete one trip around the sun, is approximately 11,400 years. Here's why that's deeply strange. For Sedna to have such an extreme orbit, something had to pull it out there. The sun's gravity alone can't explain it. Neptune's gravity can't explain it. No known object in the solar system can account for Sedna's trajectory, and it's not alone. There are other objects with similarly bizarre orbits. 2012 EP113, sometimes called Biden, follows a comparable pattern. When astronomers try to explain these orbits, they run into a problem. The most straightforward explanation is gravitational perturbation from a massive object. Something had to gravitationally nudge these distant worlds into their current paths. The popular hypothesis is Planet 9, that hypothetical super-Earth supposedly hiding in the outer solar system. But here's what doesn't get enough attention. Every simulation that successfully reproduces Sedna's orbit requires the perturbing object to have been much closer in the past. In other words, the gravitational influence that shaped Sedna's path doesn't necessarily require a planet that's still there. It could have been a temporary visitor, a rogue planet passing through the outer solar system millions of years ago could have scattered Sedna and similar objects into their current orbits, and then continued on its way, leaving behind only these gravitational breadcrumbs. Astronomer Scott Shepard from the Carnegie Institution has been mapping these extreme trans-Neptunian objects for years, and in 2018 his team published findings showing that the clustering of their orbits isn't random. The probability of this clustering happening by chance is less than 1%, which means something shaped those orbits. The question is whether that something is still here or whether it was just passing through. Now consider this scenario and tell me it doesn't sound plausible. For a million years ago, a cosmic eye blink, a rogue super-Earth ejected from a star system 200 light-years away drifts into the outer reaches of our solar system. It doesn't come close enough to disrupt the major planets, but its gravity is strong enough to perturb objects in the Kuiper Belt and beyond. It spends maybe 500,000 years in the region beyond Neptune, its gravitational wake scattering icy bodies into eccentric orbits before it exits the solar system and vanishes back into interstellar space. We would never have seen it because we weren't looking, and even if we were, our technology wouldn't have detected it. But the evidence of its passage would remain frozen into the orbits of objects like Sedna. Is this what happened? We don't know, but the evidence fits, and that's what makes it so unnerving. You see, the universe doesn't care about our models or our expectations, and that brings us to the most disturbing possibility of all. What if there's one out there right now? I want you to imagine something with me. Picture a world slightly smaller than Neptune, composed of rock and ice, surface temperature hovering around 50 Kelvin. That's minus 223 degrees Celsius. No atmosphere to speak of, because any gases froze solid billions of years ago. This planet was born around a star 8 billion years ago, but a gravitational interaction with a sibling planet ejected it into the void. It's been wandering ever since crossing the empty stretches between stars moving at 20 kilometers per second relative to the galactic background. 3 million years ago, this world entered the outer boundary of our solar system, the region beyond the heliopause where the sun's influence fades into interstellar space. It's currently 800 astronomical units away, roughly 20 times farther than Pluto, moving on a trajectory that will carry it through the outer Oort cloud before it exits back into deep space in another 2 million years. At that distance, the sun looks like nothing more than a bright star. Earth is completely invisible, and from our perspective, this planet emits no visible light, almost no infrared radiation, and isn't passing in front of any stars we're monitoring for microlensing. It's invisible, not because it's hiding, but because we simply don't have the tools pointed in the right direction to see it. Sound far-fetched? Let's look at the numbers. Based on the microlensing surveys suggesting 200 billion rogue planets in the Milky Way and factoring the galaxy's structure, researchers estimate that at any given time there should be several rogue planets within 1,000 astronomical units of the Sun. Not might be, should be. The statistics demand it. Dr. Louis Strigari at Stanford University ran calculations in 2012 and concluded that the nearest rogue planet is likely only a few hundred astronomical units away, possibly closer than the nearest star Proxima Centauri, which sits at about 270,000 astronomical units. Think about that. There could be an entire world closer to us than the nearest star, and we would have no idea. So why haven't we found it? Because we're not looking in a way that would detect it. The upcoming Nancy Grace Roman Space Telescope, set to launch in the mid-2020s, will conduct massive microlensing surveys and is expected to find thousands of rogue planets. But those will be distant objects light years away. Finding one in our own solar system requires a different approach. We need an infrared telescope with unprecedented sensitivity, scanning vast swaths of the sky, looking for the faintest heat signature, or we'd need to detect it through its gravitational influence. And that second method? That's exactly what some researchers are starting to explore. By carefully analyzing the trajectories of long-period comets that take thousands of years to orbit the Sun, astronomers can look for unexplained deviations. If a significant number of comets show perturbations that can't be explained by known planets, it could indicate an undiscovered massive object. In 2022, a preprint paper, not yet peer-reviewed, so take it with appropriate skepticism, suggested that anomalies in the orbits of several Oort cloud comets might indicate a Neptune mass object at extreme distance. The authors were careful not to claim definitive proof, but the statistical clustering they found was intriguing. If validated, it could be evidence of either a distant Planet 9 or something that passed through and has since moved on. Here's what genuinely unsettles me about all of this. We live in a cosmic shooting gallery. Our solar system isn't some isolated island. It's embedded in a galaxy full of wandering worlds, and we've only just developed the technology to start detecting them. For all of human history, until basically the last 2 decades, we were completely blind to rogue planets. We didn't even know they existed. Now we know they outnumber stars, and that some of them are likely close, but we still can't see them. It's like realizing you've been living next to a highway your entire life, but you've been deaf the whole time and just now regained your hearing. Suddenly you understand that things have been passing by constantly, and you never knew. So let's bring this all together, because here's what this actually means for us. The universe is far stranger and more dynamic than we ever imagined. Planets aren't just static objects locked in eternal orbits around their parent stars. They're nomads, wanderers ejected into the cosmos by gravitational chaos, and they're everywhere. The evidence is undeniable, from the microlensing surveys detecting them in distant star systems to the orbital anomalies in our own solar system that suggest past or present gravitational interference. Are invisible giants lurking in our solar system right now? The honest answer is maybe, and we wouldn't know. The statistical likelihood says there should be rogue planets within 1,000 astronomical units of the Sun, possibly closer. The orbital peculiarities of objects like Sedna suggest something massive influenced them. The fact that we missed Oumuamua until it was already leaving proves our detection capabilities have massive blind spots. But here's what you can take away from this. First, the absence of evidence is not evidence of absence. Just because we haven't confirmed a rogue planet in our solar system doesn't mean one isn't there. Second, our understanding of the cosmos is improving exponentially. The tools we're building, the surveys we're conducting, are finally giving us the ability to see these invisible giants. And third, this fundamentally changes how we think about planetary systems. They're not stable clockwork mechanisms, they're dynamic environments where planets can be gained and lost. What should you do with this information? Stay curious. When a Nancy Grace Roman telescope launches, pay attention to the results. When new trans-Neptunian objects are discovered with weird orbits, ask what caused them. Question the assumptions that we've been taught, because the universe keeps proving our assumptions wrong. Remember that question I asked at the beginning about invisible giants lurking in our solar system? The answer is we don't know, but the possibility is real, backed by solid evidence and statistical probability. We might be sharing our cosmic neighborhood with wanderers from distant stars, and we're only just now opening our eyes wide enough to see them. So here's my final question for you, and I want you to really think about this. If we confirm tomorrow that a rogue planet was drifting through the outer solar system right now, what would that change? Would it alter how you see Earth's place in the cosmos? Would it make you realize how temporary and fragile our stable little corner of the solar system really is? Drop your thoughts in the comments, because this conversation is just beginning, and the next decade of astronomical discoveries is going to force us to rewrite everything we thought we knew about how planetary systems work. The invisible giants are out there, and sooner or later we're going to find them. The only question is whether they're already here.